At the end of the previous lecture, I mentioned that I would like to control the character's animations based on its speed and its direction. So to make that happen, the first thing I will need is access to the direction the character is moving at all times. So I'm going to click over to the event graph and go to the very end of the update animation node chain. And then I'm going to add a calculate direction node. Given an actor's velocity and rotation, this node can calculate the direction that the actor is currently moving horizontally. In other words, along the XY plane. So now I'm going to drag a copy of the velocity variable into the graph and connect it to the velocity pin. And then I'm going to drag in a copy of the myCharacter variable. And then drag a wire out of that and create a getActor rotation node. And so now I can connect the output of that to the base rotation pin. And then finally, I can drag a wire out of the return value of the calculate direction node, select promote to variable, name the variable direction, and then connect these two set nodes together. So now I have a variable that contains a float value of the direction the character is facing in degrees around the z-axis at any given time. Okay, and so I'm already using the speed variable to blend animations together, but now I want to blend animations based on the character's speed and direction. So how can I do this with two variables at the same time? The answer is to use a regular blend space asset. A regular blend space is just like a blend space 1D, except it's two-dimensional, meaning it has two axes and can thus be controlled by two variables. Alright, so I'm going to create a new blend space by going to the Add menu in the Content browser, going to Animation, and then selecting Blend Space. And now I'm going to select the skeleton, name the asset BS_movement, and then double click on it to open it. Okay, so now I have two axes to work with, and this time I'm going to have the speed variable control the vertical axis, while the direction variable controls the horizontal axis. So in the Asset Details window, under Axis Settings, I'm going to expand the horizontal axis menu and name it Direction. And then I'm going to expand the vertical axis menu and name it Speed. Okay, so again, the direction variable will contain the number of degrees that the character is rotated around the z-axis and will range from a value of -180 to +180. And so those are the values I'm going to use for the minimum axis value and maximum axis value. And for the speed axis, I'm just going to set those values to 0 and 270 again. And then as far as the number of animations I'll be placing horizontally, there are animations for moving forward, right, left, and backwards. However, as just mentioned, the direction variable ranges from -180 to +180, which represents a complete rotation. So 180 degrees and -180 degrees actually point in the same direction, which if 0 degrees is considered forward, is backwards. And so I will actually need to place the backwards animation at both ends of the graph, for a total of 5 animations in the horizontal direction. Okay, and with 4 grid divisions along that axis, this is already set up how I need it. Alright, and then for the vertical axis, I have animations for idle, walk, and jog. Unfortunately, while this content came with a sprint forward animation, it did not come with corresponding animations for the left, right, and backwards directions like the walk and jog forward animations. And so I will not be able to include sprinting in this blend space. As a result, there will only be 3 animations going in the vertical direction, and so I'm going to change the grid divisions property for the vertical axis to 2. Okay, and then I'm going to set the snap to grid property to true for both axes. Alright, so now I want the idle animation to play whenever the character's speed is 0. And in this case, I can use the same animation regardless of the direction. And so I'm going to use the idle rifle hip animation for all 5 samples along the horizontal axis. And now I'm going to find the walk forward animation and place it right in the middle of the graph, where the direction is 0 degrees and the speed is 135. And then at the same speed, but a direction of negative 90 degrees, I'm going to place the walk left animation. And then I'm going to place the walk right animation at positive 90 degrees. Okay, and as I mentioned earlier, I'm going to place the backwards animations at the ends of the graph. Alright, and now I just need to do the same thing across the top for the jog animations. Alright, so now the blend space is complete. I'm going to toggle the labels on so I can check that I placed the animations correctly. And I'm also going to hold down the Control key and move the mouse around to preview the results. So I'm going to start at the middle idle animation and then go straight up to the walk forward animation to simulate the character increasing speed. And then I'm going to move directly to the right to the walk right animation. And as you can see, the mesh turns its hips to the right and walks in that direction. And now I'm going to move to the walk left animation. This can be a little confusing because the mesh still turns its hips to the right. However, the legs are moving backwards now, effectively representing leftward movement. And then when the backwards animations are active, the mesh's legs will move backwards with the hips facing forwards. Okay, and then the jog animations work the same way. Alright, so everything looks good, so I'm going to save the asset, and then go back to the state machine and open the graph of the movement state. Then I'm going to delete the BS Movement 1D node, go to the asset browser, and replace it with the BS Movement asset, which is the 2D version. And now I'm going to connect it to the output animation pose, and then connect the speed variable to the speed pen. And then I'm going to add a direction variable to the graph and connect it to the direction pen. And now I'm going to compile and save this and play the game. So now the mesh is animating just as we saw in the preview, blending animations based on the speed and direction of the character. Alright, so now I'm going to close out the lecture by discussing a few of the remaining properties and settings of blend spaces. So in the Asset Details window, in the Input Interpolation category, the first property here is Use Grid. With this set to the default value of false, the graph will use the default triangular method for blending. With this set to true, the graph will use the legacy rectangular grid for blending. There are some situations, such as when using wrap input, in which the legacy grid will work better. However, in most situations, using the triangular method will produce more accurate blending results. Okay, so when use grid is false and triangulation is being used, the preferred triangulation direction property will control which direction the diagonal lines in the graph go. This affects the blend that occurs when traveling diagonally across the graph. For example, when traveling parallel to a diagonal, the blend will go in a single direction from sample to sample. When traveling perpendicular to a diagonal, however, it will start blending one way up until it crosses the line, and then start blending another way up until it reaches the sample. And so, with this set to the default setting of tangential, the triangles will be symmetrical on either side, and will face outward from the graph origin. With this set to radial, the triangles will be symmetrical, and will face inward to the graph origin. With this set to none, the triangles will be asymmetric, and the animations will blend differently on either side of the graph. Alright, and then the final property in this category is access to scale animation. This is just like the scale animation property of a blend space 1D, and is used to scale the playback speed of the animation in conjunction with the smoothing. But because there are two axes, I would need to choose which, if any, should have its animation scaled. Alright, and finally, the blend graph of a two-dimensional blend space will have a couple extra toggle buttons up top. So if the useGrid property is set to false, and thus the graph is using the triangulation method of blending, then this first button, Show Triangulation, can be used to toggle the display of the connecting lines on and off. If this last button here, Stretch Grid to Fit, is turned off, then the graph will be just large enough to display its data. With it turned on, the graph will stretch across the entire panel. Alright, so that will conclude part 2 of the discussion on blend spaces.